Hey guys, this is Jin here. Just gonna give you guys a quick intros what I thought about the Shelly product I just received recently, and I'm just gonna tell you about it. How is it works and how is it fared against the other cheaper options. So I've been using Sonoff for quite a long time right now. Sonoff product is actually quite cheap. We can get something like this over from Shopee or Lazada for around 20 to 30 bucks. But this is actually more the inline replacement, meaning there's a power wire coming in and power wire coming out. So if you want to put it in your normal regular light switch, usually you get something like this. This is a smaller version that actually go inside your switch and then connected the switch cable from here, and then it have a functionality to actually trigger your switch on and off. This is slightly more expensive, but today we're gonna review something much more better quality in my personal opinions, Shelly X1 and Shelly X1PM. So shall we begin? So let's take X1 first example. Let me open up the casing. So as you can see that compared to the Sonoff Mini, is actually slightly smaller. In fact, it's a lot much more smaller than the Sonoff Mini, as you can see here the size. So definitely can fit in more better spaces. And compared to Sonoff Mini, this is the R1 version. R1 version, the antenna is actually outside. So that's one of the bad part about this, because that means that you have to figure how to put this thing and stick it somewhere near the things, and it doesn't work that well. And then you can see that the connection pin here, or power usage, as you can see, the Shelly 1 is actually able to support a relay output up to 16 amp. This is actually quite high. This is actually as high as no normal socket can go, whereby the Sonoff one is only support up to 10 amp. As you can see here, it's not that clear because it's printed on the plastic. And the Shelly 1 win a lot because it doesn't have an antenna. It's actually built-in antennas, whereby the Sonoff R1 series, Sonoff Mini R1 is only have the antenna. Only until the recently R2, they actually removed the antenna requirement. So let me open up the Shelly one. Okay, here's the Shelly one. So let me show you the thing that I found very interesting in my modem. As you can see, we have the rectifier coming in, and this is the buck converters for them to turn down this AC voltage into a 12 volt. And one thing I like the most about the Shelly is actually they are using a 12 volt relay. As you can see here, this is a 12 volt relay, and it actually support up to 16 amp switching voltage. And this is actually quite good, because usually the relay, a small device like this, you see usually 5 volt relay. I can open out the Sonoff for you to see later. And the best thing of, it actually come with the GPIO pin open up listed for you to connect stuff. And if you can notice here, they actually provide a little bit of window here for you to plug in the devices, and this is very good for people who like to hack the stuff. You can see it's actually a rubberized cover. You can take it off, and when you put it back in again, you can see the connector is actually come out. You can actually connect devices, sensors into here very easily without any soldering. So let me open up the thing. You can see from the back. So as you can see here, this board is actually come with a built-in antenna here. And rather to using an ESP8285 with a built-in flash, this thing come with a flash chip. So this flash chip, I believe, is actually 2 MB. This is a 2 MB flash chip, and well, it's definitely much more space for you if you're gonna customized this thing, or using ESP Home, or even using the Shelly own software itself. It had much more flash space than a common ESP that use ESP8285 used in the Sonoff, because they only have 1 max space. More memory storage for your program is always better. And you can see here, he actually using a power management IC. So this is the IC that managing the conversion power from the 240 volt into 12 volt, and then switching down to another 5 volt for 3.3 volt and 5 volt for the ESP to use. So this is actually fairly expensive equipment because it's a purposely made IC that designed to switching power switching regulated down a 240 volt down to 12 volt and 5 volt. So you can see the component. We had the inductor here, a very good quality capacitor, and we do have the switch, the bridging here. So this bridging is actually for the 12 volt DC and the high voltage DC. So because they actually have a built-in what they call it, power regulator itself. So by changing this voltage here, you can actually select what kind of input power you can use. So this thing can technically power by a 12 volt or 30 to 50 volt DC voltage rather than just AC. So if you put this thing here, this connect switch here is actually running on a 30 to 50 volt. If you change the jumper into these positions, and then this thing running on 12 volt only. So this thing will come in 12 volt, bypassing this regulator, and then supplying the rest of the components with the thing. So you can actually use this thing without actually connecting to AC. So this is a DC straight out of the box, AC and DC compliant devices. So these Sonoff devices only can use for AC only. You cannot connect this to a DC voltage. So that's it. That's about it. So this build quality is actually very clean. And it's very small as well. I like it. So let's open up the Sonoff one and see right now. So let's see the Sonoff one, what the inside, how it looks like. Okay. So as you can see, they are using a 5 volt relay. So although the relay here spec'd up to 16 amp, but Sonoff only expected us to connect at 10 amp max in the first place. So yeah, I don't think this relay able to do 16 amps as well. And again, it's a 5 volt relay. So why is the difference between 5 volt relay and the 12 volt relay like this? It's very simple. Relay is actually a magnetic devices that actually clamp the two contact together when given power. So a 12 volt relays will use a less energy, the less currents to actually clamp this thing out, and they're actually holding much more stronger than a 5 volt one. Like for example, a 12 relay maybe only need like 30 or 40 milliamp just to close the circuits and stay there for a very long time, whereby 5 volt might need up to 100 to 200 milliamp to do so. And because these kind of circuits that convert the electricity from the AC voltage into DC voltage might not able to supply such a big currents. So sometimes we have the problem that relay doesn't fully close properly, and they actually have arcing issues. So imagine that this thing is a switch itself. When it's closed a bit too slow and not fast enough, or sometimes it's not too strong that the thing actually doesn't stick properly, then will make slightly arcing from the contact to the contact when the AC is powered on. And because of this can burn the contacts, and then sooner or later they will fuse the contact together and the relay stuck. That's the reason why a lot of relays, that cheap relay, having this issue, because that they're using 5 volt. Using 12 volt can solve a lot of this problem because the time the two contact closing together will be very fast, and then reducing the arcing from happening. This took some time, but this definitely not a very easy to service components. Everything was clipped in very heavily, and it's very hard to remove it. So as you can see here, we have our Sonoff devices. So my personal review is, as you can see, they are not using a very high quality relays, just a standard relays and a wide capacitor here. At least they use an SMD, what do you call it, the inductor. But compared to the inductor here, this inductor looks much more high quality in the first place. This is a very basic inductor. So okay, look behind the board here. So the board here, we can see they are using actually ESP8285. So this is a built-in 1 megabyte of storage. Basically, it's a flash storage for this one. And there's a couple of the things, and we have the, I think this will be a full bridge rectifier. Yep. full rectifiers with the fuse relays, and then we have a drop down voltage. So compared to the Shelly, so this thing actually using a capacitor dropper, as you can see here, there's a one capacitor dropper here to reduce the voltage from AC to DC, and then the DC voltage would then be shot down to, I think this transfer over to 3.3. This is a 5 volt from 3.3. The AC voltage will come in here, and then this capacitor, the capacitor array here, will do a capacitor dropper to actually drop the voltage from 220 AC down to 5 volt. And then the 5 volt AC would then be having through this what do you call it, power regulator, LDO, and then drop down to 3.3 for this thing to use. So we do have a balun here. Yeah, as you can see, for you to flash this thing is very hard. There is the flash pin here, as you see, 12 port, 5 volt 3.3s, and RXCX, and we have 2 GPIO pin here, which is like, this is tough to solder. This is very tough to solder actually. So if you plan to actually modify these devices, I would suggest you get something like Shelly, which have every pin that break out for you. Then you can easily use them compared to this Shelly 1PM. So as you can see, same size, exactly same size, and the difference between the 1PM and the 1 is actually PN stand for power monitoring, power metering itself. So this is actually definitely a good addition. Let me open this up. So same things as you can see, and then you notice one thing. So this thing have an antenna that come in with it, and I unplugged this antenna earlier. So this antenna is a 2.4 gig antennas that's faced on here. So if you ask me, I would definitely recommend getting a Shelly 1PM simply because antenna is actually placed outside of this, and it's a high quality certified antennas. Now, the reason is because if you put this inside, like for example compared to this Shelly 1PM, the antenna is actually here. So imagine that this small corner antennas is getting more blockage from your switch itself compared to this. The whole piece of here will be the antenna devices, the antenna hole itself. So this thing will definitely have better reception compared to a PCB antenna. And compared to an external like this one, it's also much more easier to install because everything is still inside and it's stick inside here nicely. So as you can see, they are using the same HF HF devices that are running on 12 volt relay. So well, exactly same here. You can see 012 for 12 volt. The strike relay itself can support up to 16 amp. And you notice there's a few different here. There is extra one more capacitor, I guess simply because they try to split this capacitor into 2 instead, because they run out of space. You can see the space is kind of packed, jam-packed. Why is it so jam-packed? Well, it's all behind, linked up behind. So as you can see, the smallish connector here is actually connected to this little small connector devices. There's a hole for you to put in the connector, the antenna connector to plug into here, and there's a switch here that's for reset function. And you can see this is our ESP8266. We have our 2 Mac flash chip here. So as you can see here, we do have a C-Frons QH16, which divide by 8. This means this is a 2 Mac flash chip. And then we have a BL0937 from Bailing, Shanghai Bailing monitoring IC. So this is energy meter IC. So this is actually quite a very particular, because this is not very well known power IC, but it's actually been used in a lot of the China devices. So I would say this is very accurate. I like this design because you see how much small component back here. Just have a view on this. So just in terms of personal favor. As you can see, I put it slightly, you can see this whole thing has been pretty much cleaned nicely. There is not much solder residue, or the soldering is actually pretty much well soldered. The board is very clean, that's for sure. Whereby you see the quality of Sonoff is, you can see here, it didn't use a flux or the PCB cleaner to clean out all the residue flux here. You can see in the angle that this is actually a bit dirty here and there. It might not cause any problem in the short run, but in the long run, the flux might actually, eat up the solder mask itself. But I don't think it's a big concern, because I don't think you're gonna plan to use this more than 10 years anyway. And for the front as well, you can see that the design is pretty much generic, and the cutout, the PC board is actually fairly thin. This is one of the things that I observed as well. You see, they're using a 0.1 just to make the size 0.1 mm PCB board compared to the 1.6 standard PCB boards, just to save a bit of the cost, but also make this thing a bit flexy in the first place. So today, just kind of reviews on the hardware stuff that I found out. So the verdict is actually very simple. I like Shelly design. Shelly design is fairly complex, and you can see they actually put a lot of thought into making it very easy to use for the user. They have the GPIO pins. They have the for the Shelly 1 instead, they have the AC and DC switch it. So for example, if you're gonna switch it over to DC, you can just plug in the DC's power, I think 30 to 50 volt easily, or you can just change the jumper here into here for it to power using 12 volt. So this is very useful if you want to power something using 12 volt DC or 30 or 48 volt DC in the first place. This is very good for like your home's devices that run on DC, whereby this Sonoff cannot do that and only support AC only. Next is also, it's actually very easy for you to actually flash the devices and put in extra sensor on it. It even designed the plate to be easily opened up with the cover itself here, as you can see here. That's easy to access cover, the rubber cover. You can plug it out and can plug it in again easily. So again, this is one of the good things about these devices. And last but not least, this is what is the matter the most. A 12 volt relay is pretty much better than a 5 volt relay like this. As you can see, this is a HF, a very much more reputable relay compared to I think a bit tough to say. I have not much opinion on this design, but I not think Golden is a very reputable relay design. It's much more a generic relay. So if you have concerns to switching like high voltage, I would suggest that you get Shelly instead. High power usage devices. I would not suggest you to switch like 12 16 amps straight away, but switching big devices that like aircon, everything is not recommended. But if you're gonna switch something like your home's normal usage, this at the high power one, Shelly device is much more better compared to this 5 volt relay, definitely. Then last but not least is I like the fact that they actually use power meters IC, PMIC, the power supply IC, and they have 2 MAC flash. So this is a very clean, nice board design. And I will say that if you have the money, this is the thing to get. And last but not least, it's actually very, very small as well, as you can see here. And we come back to the Shelly 1PM. The 1PMs have a proper monitoring chip here, and then with the flash chip here, there's a 2 MAC flash as well. And we have a proper antenna route out from here, so you get a much better receptions. So if you're gonna ask me, I would say that the price difference, if you can afford it, get over the PM Shelly 1PM, simply because that is actually using a 12 relays and you have the very accurate power monitoring IC. That's about it. If you're gonna ask me about the concerns that I have, is of course, again, this live switching, everything, these are switching on live. So there is no separation between a live a high voltage segment and a low voltage segment. So this might be a slightly concern for people who actually gonna touch the keyboard board a lot. But in terms of Shelly usage, because this thing actually lives inside the socket board, you'll be pressing the socket and the socket switch is actually not connected straight to the live voltage. So I guess it's okay. So that's what. Thank you. Next video, we're going to talk about the software side and how this thing fare to each other on their stock OS, their stock software, and we're going to try to flash it into Tasmota and see what kind of function we can get here, and we will try to integrate this into Home Assistant.